observe Emily, our model chemistry student, as she goes about experimenting in the lab. Emily always wears proper safety gear when handling dangerous substances, including a lab coat to protect exposed skin, goggles, and protective gloves. Emily always reads instructions in advance to ensure proper precautions are taken and that all her materials are gathered and prepared. She always remains focused on the task at hand, leaving all distractions out of her reach. Watch as Emily carefully and precisely measures her chemicals while performing the experiment. Like any good chemist, she knows that a precise experiment is a successful experiment. When smelling a chemical, Emily always asks permission first before carefully wafting the vapors towards her nose to avoid a dangerous concentration of fume. She records her findings accurately and truthfully, with precise descriptions and comparisons. Finally, Emily always... Wait, what are you doing? No, don't. This is a safety video. Okay. You know what? Cut. Just use some common sense and don't taste the chemicals. The chemicals we use in class could be neurotoxins, carcinogens, or anything in between, so why would you take the risk? You could cause serious damage to your digestive and nervous systems, become permanently disabled, cause your organs to shut down, or even go into anaphylactic shock. Also, you could die. I know sometimes it's tempting when something is the color of Kool-Aid, but just don't do it.
Looks like water, so why can't I drink it?
There are a plethora of colorless chemicals that, when left unattended on a lab table, could very much appear to be water. As you can see from our indicator strips, one of these beakers did contain water, but one contained very low pH hydrochloric acid. Could you tell the difference just from looking at them? By the time you realize you're drinking acid, it could be too late. Never assume something is water.
What if I'm sure it's a drinkable liquid? Can I still drink it?
Even when dealing with non-toxic or consumable liquids, never drink from a beaker. It could contain traces of dangerous toxins from previous experiments. Just use some common sense and don't taste the chemicals.
On to our next topic, strong organic acids. Organic acids occur naturally and are a part of almost every living thing. They are essentially all the acids that contain carbon. The most common kind of organic acid is carboxylic acids, which contain the carboxyl group.
Organic acids are typically considered weak acids, but this does not mean that they are harmless. However, in its more concentrated glacial form, it can be very dangerous and cause a lot of damage to skin and internal organs.
When working with these acids, avoid ingestion as they can be very dangerous. For example, a 5-gram dose of powdered oxalic acid could be fatal.
Make sure to also avoid contact with skin and eyes to avoid severe irritation. If contact occurs, flush with water and seek medical attention.
Like our model student, wear protective clothing, gloves, and goggles. Avoid using latex gloves, which can be easily penetrated by these acids, and instead use nitrile ones, which can resist corrosion. Also, make sure you are working in a well-ventilated area or under a fume hood.
Always store acids of any kind in a secure storage area, in a dedicated cabinet that is air-conditioned. The acids themselves are to be kept in airtight and well-sealed containers such as glass jars.